Hi students, today we are going to see the third part of the similarity. Students, do you know this? You have studied this in 9th standard. What is the meaning of this? These two triangles are similar or congruent. These two triangles are congruent. You have studied in 9th standard. What is the meaning of congruency? It means exactly equal. But if I show my photo to you, then what will happen? Is that these two are congruent with each other? No. Then what is this? They are similar to each other. Then what is the difference between the congruency and similarity? It is very simple. Congruency means exactly equal, and similar means looking like as but not equal. So today we are going to see the similarity of two triangles. Exactly what do you mean by similar? What it says? It says that if the two triangles are similar, then its sides are in proportion. So AB upon PQ, BC upon QR, AC upon PR. If the triangles are similar, then sides are in proportion, and one corresponding angle is congruent. Angle A is congruent to P, either angle B is congruent to angle Q, either angle C is congruent to angle R. But how can we show that the two triangles are similar? Yes, there are three tests to show the triangles are similar. First one is AA test of similarity. What do you mean by AA test? It's an angle, and angle test. Then second test is there, is called SAS test. That means side, angle and side test. And the third test is there, is called SSS test. It means side, and side. If all the three sides are in proportion, then two triangles are similar. So let's see. In AA test, AA test of similarity, angle test. For this test, we need some angles. One is alternate angle. Second one is corresponding angle. Third one is vertically opposite angle. Fourth is each of 90. And the fifth one is common angle. These 5 angles are very important for us to show the AA test. When the alternate angles comes, you know it well. If the two lines are parallel and it's make a shade like this, either like this, either like this. These are alternate angles. These are the alternate angles. But it has a condition that line should be parallel. Then, what about the corresponding angle? Again, we need the lines are parallel. If there is a transversal, then it makes the corresponding angle like this, either like this. These are the corresponding angle. For these two angles, alternate angle and corresponding angle, line should be parallel, otherwise they will not come. Then what about vertically opposite angle? It is very simple to identify. These angles are called vertically opposite angles. Angle AOB is congruent to angle COD. These are the vertically opposite angle. Then each of 90. It's very simple. If the sign 90 comes there, then we can say that these angles are each of 90. But what about the common angle? See in this figure. This is ABC and there is DE. If you split these two figures, you will get two triangles. One is ADE and another one is ABC. In these two, see that the letter A is double and that is called a common angle. But now there is a one twist. Can you tell me about this diagram? See this diagram. This is A, this is B, this is C and this is D. If I split the figure, then I will get two triangles. One is ABC, another one is BCD. Can you say that angle B is a common angle? Can you say that angle C is a common angle? No, here you cannot say that B and C are the common angles. Why? Because from the B angle there is a one line which is passing through that angle. It makes two angles at the point B. And same thing it will happen for the angle C. Again there are two angles, therefore C is not a common angle, B is not a common angle. And there is a simple trick to remember that. If any line is passing through that angle, then that angle is not a common angle. These five angles are very important for us to show the AA test. Okay, now we are going to start the next step is SAS test. Side angle side test. If the two sides are in proportion and one angle is congruent, then we can say that these two triangles are similar by SAS test. Now see this figure. This is triangle AOB and triangle COD. In this one, this is given 4, this is given 8, this is given 6, this is given 12. See this. In these figure, AO upon OC equals to 4 upon 8 equals to 1 upon 2. Then BO upon OD equals to 6 upon 12. You will get it 1 upon 2. So from 1 and 2, we can say that AO upon OC equals to BO upon OD. Sides are in proportion and the middle angle, which is vertically opposite angle, angle AOB is congruent to angle COD. Angle AOB is congruent to angle COD because this is vertically opposite angle, and therefore triangle AOB is similar to triangle COD by SAS test of similarity. Always remember the point. In SAS test, two segments are in proportion and one angle is congruent. Then we can say that the triangles are similar by SAS test. Now we are going to see the third test is called as test of similarity. Now see, in this figure you will find these are the two triangles. One is ABC, another one is PQR. Here AB is given 4, PQ is given 8, DC is given 3, QR is given 6, this is given 5 and this is given 10. Observe these two figures. What do you observe? AB upon PQ. If you take the ratio of these sides, you will get it 4 upon 8 equals to 1 upon 2 is the number 1. Then BC upon QR equal to 3 upon 6, again 1 upon 2. Third, AC upon PR equals to 5 upon 10 equals to 1 upon 2. See the ratio of these three from 1, 2 and 3. We can say that AB upon PQ equals to BC upon QR equals to AC upon PR. It means all three sides are in proportion, and therefore we can say that triangle ABC is similar to triangle PQR by SS test of similarity. And these are the three tests we have seen. First one is AA test of similarity, second one SAS test of similarity, and the third one is SSS test of similarity. These are the three tests which are very, very important for us to show the triangles are similar. Now let's see the examples which are related to this. See the first example. This is triangle ABC and this is PQ. This is given 75, this is also given 75. Is that triangle ABC is similar to triangle QPC? Okay, now always remember the one point. If you want to show that triangles are similar, first always split that triangles. So I am going to split the figure here. This is triangle ABC and this is triangle PQC. Then make the markings. B is given 75, P is given 75. To show the triangles are similar, we need three things. Either from AA test, from SAS test, either SS test. Remember that AA test is very important for us. And for the AA test, we have 5 angles: alternate angle, corresponding angle, vertically opposite angle, each of 90, and the last one is a common angle. Always remember these 5 angles. So I am going to ask one by one, is that alternate angle and corresponding angles are there? No, because lines are not parallel in these figures. Then, is that vertically opposite angle is there? No, there is no vertically opposite angle. Is that each of 90 angle is there? No, there is no 90 angle. So I am going to ask the question to this one. Is that common angle is there? Any letter is there? Yes. One letter is double, that is called a C. And this is a common angle. So therefore I get the two angles. One is B, is congruent to P, and C is a common angle. Therefore I can write it in triangle ABC and triangle QPC. Angle B is congruent to angle P because each of 75. And then angle C is congruent to angle C. This is called a common angle. Therefore, triangle ABC is similar to triangle QPC by a test of similarity. Therefore, these two triangles are similar by a test. Always remember, you have to ask the question this one, then you will get the correct answer. Now let's see the sum number second. These are the two triangles, one is ABC and another one is PQR. Here the sides are given 6, 10 and 8. This is 3, this is 5, this is 4. Again the question comes, is that triangle ABC is similar to triangle PQR? Now observe this figure. All three sides are given. It means these two triangles will be similar by S test. For that, you have to show that sides are in proportion. So let's see. AB upon PQ equals to 6 upon 3. So 3 ones are 3 twos are. Then second, BC upon QR equals to 8 upon 4. 4 ones are 4 twos are. Third one, AC upon PR equals to 10 upon 5. 5 ones are 5 twos are. So what do you observe? From 1, 2 and 3, all three sides are in proportion. BC upon QR equal to AC upon PR. And therefore we can say that triangle ABC is similar to triangle PQR by SS test of similarity. This is the second sum which is related to SSS test. Now I am going to ask you the one question. Suppose there are two poles. This is the one pole and this is another pole which has a height 8 meter and it has height 4 meter. If the shadow comes down, then this is AB pole and this is CD pole, and its shadow is DQ and its shadow is DR. If its shadow is 12 meter, then what will be the shadow of this pole? Remember that poles are always perpendicular to the base. If I join this, these two triangles are already similar. Why? Because shadow comes from sun and therefore no need to show that these two triangles are similar. They are directly similar. So we can write it, triangle ABQ is similar to triangle CDR. And if these two triangles are similar, we know that sides are in proportion. So AB upon PQ equals to AB upon CD equals to BQ upon DR equal to AQ upon CR. Now substitute the value. AB is given 8, CD is given 4, BQ is given 12 and DR we have to find out it. If you cross multiply, you will get DR into 8 equal to 12 into 4. Now, this 8 goes on that side. So, DR equal to 12 into 4 divided by 8. 4 ones are, 4 twos are, 2 6 are. Therefore, DR equal to 6 meter. And always remember that you have to write your answer in full statement. Therefore, the shadow, the length of shadow of second pole is 6 meter. So this is directly related to the triangles are similar. Now let's see the another sum. See the sum number 4. This is triangle ABC, and there is another triangle. This is P and this is Q, and you have to show that triangle CPA is similar to triangle CQB. Now here we have to show that the triangles are similar. So I told you the one idea. If you want to show the triangles are similar, first split the figure. So I am going to split the figure. Triangle CPA. Where is CPA? This is the CPA. This is C, this is P, this is A. Then another one is CQB. This is C, this is Q, and this is B. Here the 9th triangle. Now I want to show that these triangles are similar. So the one angle is given. We have to find out the another angle. I told you the 5 angles. First one is alternate angle. Second one is corresponding angle. Is that both the angles are there? No. Why? Because there are no parallel lines. Third one is vertically opposite angle. Again, that angle is also not there. Fourth one is each of 90. It is already there. Now we have to find out the fifth angle. Is that common angle is there? Yes. C is a common angle, because that C letter is doubled, but no line is passing through that C angle. Therefore, C is a common angle. So we can write the proof here in triangle. First, you have to write it in triangle CPA and triangle CQB. Angle C is congruent to angle C because of common angle, and then we can write it angle CPA is congruent to angle CQB, each of 90, and therefore triangle CPA is similar to triangle CQB by a test of similarity. Therefore, these two triangles are similar by a test. Always remember the first trick. If you want to show the triangles are similar, first rule is split that figure. Second rule, make the markings. It means what is given in that figure. Third rule, find the next angle by that 5 angles. Alternate angle, corresponding angle, vertically opposite angle, each of 90, and common angle. Now we are going to see the sum number 5. This is triangle ABC and this is given angle D. In this figure, given is angle BAC is congruent to angle ADC, and you have to prove that CA square equal to CB into CD. Now I am going to tell you a simple idea. How can we prove this? In second part, we have seen 3 theorems. One is BPT, second one is ITPL, and third one is angle bisector theorem. How can I prove this example? You have to ask the question, is that in this figure BPT is there? When BPT will come? If the lines are parallel. lines are not parallel. So therefore, BPT will not come. Is that angle bisector is given? No. Angle bisector is not given. Therefore, ABT will not come. Third, intersection of three parallel lines. Is that three parallel lines are there? No. It means BPT, ABT and ITPL will not come. Which is the fourth thing? That you have to show that the triangles are similar. If you follow this rule, you can solve any sum. Here I have to show that the triangles are similar. So I told you the three rules. First rule is split the figure. So the angles are given. On that basis, I am going to split the figure. One is BAC. This angle is congruent to angle ADC. This is ADC. These two angles are congruent. The first rule, split the figure. Second rule, make that marking. It means whatever is given. And the third, you have to find out it from pi angles. Is that alternate angle and corresponding angles are there? No, because lines are not parallel. Vertically opposite angle is there? No. Each of 90 is there? No. It means the fifth angle is a common angle. Yes. Angle C is a common angle because nothing is passing through that angle. So here we can write the proof. First you have to write the name of triangle. In triangle CBAC and triangle ABC. Angle C is congruent to angle C because of it's a common angle. Then angle BAC is congruent to angle ADC. This is given. And therefore, triangle BAC is similar to triangle ADC by AA test of similarity. Always remember, if the triangles are similar, then sides are in proportion. So which sides are in proportion? BA upon AD equals to AC upon DC equals to BC upon AC. So I am going to write what I need. I need CA means AC and I need CB means BC. I need CD. So I am going to take these two ratios. AC means CA upon DC means CD, BC means CB and AC means CA. If we cross multiply, we will get it CA square equal to CB into CD. This is the best and fantastic idea to solve any sum. Always remember, I am going to tell you once again. First, if you want to solve any sum, ask the question. Which are that question? Is that BPT is there? When BPT will come, the lines are parallel. If the lines are parallel, then BPT will come. Second is if the angle bisector is there, then angle bisector theorem will come. Third, if the three lines are parallel, then intersection of three parallel lines will come. And if all three things are not there, then you have to show that the triangles are similar. Triangles will be similar by three tests: AA test, SAS test and SS test. But most important is AA test of similarity. And for that, we have to use 5 angles: alternate angle, corresponding angle, vertically opposite angle, each of 90 and common angle. Find all 5 angles, then you will get the second angle and show the triangles are similar. If the triangles are similar, then sides are in proportion. You will get the answer immediately. So student, best of luck and thank you.